Hi everyone! Welcome back to our channel. I'm Erl.
I am Khea.
I'm Kryza.
I'm Cyrean.
I'm Adrianne, and we are the Animath.
If you have no idea what Animath is, we are the group of college students from the University of St. LaSalle who uses YouTube as a platform to share our knowledge about mathematics with our fellow students.
If you also find math interesting, make sure to hit that subscribe button below for you to be notified whenever we post new math contents. Without further ado, let's get straight into the video.
First and foremost, what are we going to talk about today, Erl?
Today, we're going to talk about violins.
What? How is violin related to mathematics?
It is, and these facts will surprise you.
Today's topic is entitled From Violins to Videos, inspired by the book by Ian Stewart. But before we proceed, Adrianne, can you define what a violin is?
A violin is a string musical instrument of treble pitch played with a horse or bow. The classical European violin was developed in the 16th century. It has 4 strings and a body of characteristic rounded shape, narrowed at the middle with 2 F-shaped sound holes. For today's video, we're going to talk about the expert who discovered the sound waves from the violin can be used to project light and different colors.
But first, let's start by understanding the concept of sound and vibration. Sound and vibration could never be separated from each other. The vibration particles caused by sound bump into each other, which makes the sound waves travel far from their actual source. Experts discovered that the sound waves from the vibration of the strings of the violin were helpful in mapping electricity and magnetism. This is where pure and applied aspects of mathematics combine to yield something far more powerful and compelling than either could have produced alone.
Fun fact, do you know that children who play instruments like violins are able to complete complex mathematical problems better than peers who do not play instruments? Amazing, right?
In the book Nature Numbers by Ian Stewart, he explained that this concept helped invent televisions, radios, and radars. The idea started when Euler's and Bernoulli's works concluded that the basic vibrational components are the sinusoidal waves. Later on, Euler formulated the wave equation, which was used in the fields of fluid dynamics, theories of sound, and theories of electricity and magnetism.
Years later, it led to the discovery of electromagnetism by the physicist Michael Faraday. It was Faraday's successor James Clerk Maxwell, a mathematician who used mathematical equations to describe Faraday's idea of the distributions of magnetic and electrical charge throughout space. Finally, this gave birth to the existence of visible electromagnetic waves that travels with light with different frequencies which produce different colors.
How cool is that? A simple musical instrument was the root of the television that we're currently enjoying. As years go by, people benefit from the same concept by creating different social and educational platforms that maximize the concept made by the collaboration of many great minds.
Now, let's move on to the evaluation part of our chapter review. We evaluated the chapter based on 3 criteria: content, organization, and cohesiveness. In terms of content, the discussion in the chapter was well written. Even a lot of concepts and ideas were stated. Since different mathematicians were mentioned, along with their contributions, the chapter was understandable and easy to comprehend.
In the account of organization, Stewart introduced the concepts, ideas, theory in a very organized and concise manner by stating them one at a time. Additionally, the main idea or focus was clear despite the fact that there are a ton of subtopics.
Lastly, in terms of cohesiveness, the concepts and ideas presented in the chapter are related and connected with one another. Therefore, we wouldn't be aware that the mapping of magnetism and electricity, which are the aspects of the same fundamental force that underpinned the development of radio, radar, TV, and many other technologies, was made possible by the simple observation of the movement of a violin string, if it weren't for this book.
Furthermore, we would recommend this book to those who enjoy reading about complex concepts and math enthusiasts to read.
The book Nature Numbers by Ian Stewart is a helpful guide in making us more knowledgeable about the things that were created using the help of mathematical formulas. If you want us to tackle more topics about this book, make sure to leave a comment below.
We hope that you learned something from us because we enjoyed sharing our knowledge about this topic. and I hope you enjoyed it as much as we do. Again, don't forget to hit that like button and subscribe to our channel Animath, where we post mathematics related contents. Once again, I'm Erl.
I am Khea.
I'm Kryza.
I'm Cyrean.
I'm Adrianne, and we are the Animath.